2 questions, yes.
How many questions are going to be on our final?
Oh my god.
On the final, I don't know yet. Somewhere between 50 and 75. Right about that. That was your question? Yes, multiple choice. Okay, last 2 theorems of the chapter right here. Volume of a pyramid and volume of a cone. Everybody got them written down on their toolkit?
Yes, sir.
Toolkit you can use, remember, on the test and on the final. Alright? You can use any toolkit that we've ever made on the final. Please take that out of your ear. Everybody else, please take those things out of your ear while we're doing this part, okay? Alright. Okay, let's head back over to this part. So, third idea here. We're going to find the volume. No, it's not 12. Okay, I'm going to give you a pyramid here. That's it's going to be challenging to draw. It's going to be a regular pyramid. And it's going to look like this. A little bit skewed over there. Kind of like that right there. Since it's a regular pyramid, every side of the base will be the same. And we're going to call that 2 centimeters. And we're given a height of 5 centimeters total. So, to find the volume of this particular pyramid, we can check back to our toolkit. It says it's going to be 1/3 the area of the base times the height. So we're going to write that down. We're going to say, okay, we know volume must be 1/3 area of the base times the height. We know a few of these things already. What do we know already? Just shout it out. We know the height. Very good. So I got 1/3 area of the base. The thing that I don't have, height is 5 centimeters. Now here's the challenging part. Notice that this base is what type of a shape? This is a hexagon, and we need to find the area of that hexagon, which is challenging. So what I'm going to do is I'm going to draw the hexagon flat on the surface here. Just like this. And I need to find the area of this hexagon. So I'm going to start off by labeling what I know. That's 2 centimeters. I'm going to get a central angle. How do I get a central angle of a regular polygon? Say again? That's right, 360 total degrees in a circle divided by number of sides, which is 6 sides in this case, which means that I have a 60-degree central angle right here. Does everyone follow me so far? Yes? You good? Where are you going? Okay, good. So now, I have a 60-degree central angle here. I'm going to take this triangle, I'm going to draw it outside the hexagon. It's going to look like this. If it was 60 degrees, I cut it in half, that becomes 30. This is 90. This angle down here has to be left over 60 degree apart. Now, what is that base on the bottom of my triangle that I just drew? It's 1. Yeah, it's half of what it was before, so 1 centimeter. I'm going to call this A. What does that stand for? Apothem. Good. So I know the area of this base, area must be 1/2 the apothem times the perimeter of the base. That's something we learned back in chapter 11. So that means that I'm going to have 1/2 the apothem. I don't know what that is yet, but the perimeter I can easily get since each one is 2 centimeters and there's a grand total of 6. So what's the perimeter? 12. Okay, we know that part. That's easy. Let's get A. Now, maybe you forgot your special 30, 60, 90 triangles. So I'll use a little bit of trig here. And I'll just say that the tangent of 60 degrees has to be the opposite side, which is A, divided by the adjacent side, which is just 1. So therefore, A, the apothem, must be the tangent of 60 degrees. Now, we all have calculators, so we can ask the calculator, okay, 60 degrees, give me the tangent, and it is 1.73. So now I know my apothem is 1.73. So I take that information, and I put it right here into 1.73. So that's going to give me a total area of, who can help me out? Please tell me what the area of the base is. 1.73 times 12 divided by 2. 10.38? Yeah. 10.38. Okay. So I'm going to take that information. That is the area of the base. I'm going to plug it straight into my volume formula, and I'm going to come up with an answer of 1/3 times 10.38 times 5. So I get a grand volume of, help me out, who can do that? 17.3. Daisy says 17.3. Can I have someone verify that she is correct? Yes, I heard 2. Good. So that is centimeters. And notice that we're going to cube it because we're talking about volume. So we're always cubing. Okay, last idea here. You're going to give yourself a cone. We're going to talk about the cone. So draw yourself the best cone that you could possibly make. All right. Okay. We know that the height of our cone is going to be 10.2 centimeters, and the radius of our cone is given to us at 6.7 centimeters. We're trying to find the volume of a cone, okay? So the first thing we're going to do is we're asked to find the volume of a cone. We're going to go check our toolbox. It says the volume of a cone is 1/3 pi r squared h. So we bring that over to our problem that we're working on, and we say the volume must be 1/3 pi r squared h. So that means we're going to have 1/3, 3.14. The radius is 6.7, so we're going to square that and then multiply it by 10.2 because that's our height. So we'll run straight into the calculator. And here's how I'd suggest doing this. I would go 6.7 squared times 3.14 times 10.2. Get your answer. And then divide all of that by 3, which gives us 479. And what's my centimeters here? I got centimeters. So volume is 479 centimeters, and we're going to cube our answer because we're talking about volume. All right, that's it.
Can we leave out the decimal point?
Did I leave it out? What was it?
37.9.
Oh, we should round to, the book always wants us to go to 1 decimal place, so we'll go to 0.2. Thank you for bringing that up. So that should be 0.2 centimeters.